All right, here we go. All right, this is number 8, test review. It is Friday, March 8th, is that correct? So your quiz is Wednesday, March what? 13th. March 15th? 13th. Is that right? And that's Wednesday, March 13th, and your test is Friday, March 15th. Correct? Okay. Now, remember, there's not a lot of time left for you to gather points to raise your grade or lower your grade. Remember, it's like a batting average, right? In baseball, the more times you're at bat, the harder it is to make a change in your batting average, right? Yeah, easy. So it could be a good thing or it could be a terrible thing, depending upon what your grade is. All right, I want to talk about Bernoulli's principle. Okay, this is a wing called an airfoil. An airfoil is just a fancy way of saying an airplane wing. Okay? All right, now, that's coming straight out of the board. It's coming straight out of the board. And this drawing is called a cross-section. Now, I did this period 2, and I found that a lot of people didn't know what a cross-section was. Is that true? You don't know what a cross-section is? Now they're pointing at me. I have no idea. I never realized that. You guys don't know what a cross-section is.
Like driving with roads? What kind of a cross-section is?
No, not driving with roads. Okay. I'll explain, okay? I'll explain. This is the airplane wing coming out of the board, right? Right? Yes? Yes? Very long, correct? And the cross-section will be, I'll cut it here, and then I see this section, the flat section, right? Yes? Such as if I have a meter stick, right? This is a view of the meter stick, right? But a cross-sectional view of this meter stick, like what does it look like on the inside? So a cross-sectional view of this meter stick would be, this is cross, right? And then the cross-sectional view would be that. You see that? Can you see that? Would be this part right here. Would be the cross-sectional area. Do you understand that? Right? Somebody take out a piece of paper. Gabe, take out a piece of paper for me.
I got no paper.
Somebody have paper? They have no paper. I work in a very, very poor school district. My students don't have paper. It's really, it's terrible, really. I feel so bad for them. Okay, thank you, Max. Max is one of my more wealthy students. He has paper. Okay. Now this is a piece of paper, right? The cross section would be this. Would be this area here. Can you see that? Would be this. That's the cross section. Just that real thin. It's real thin. Yes, you get that? What a cross section is? Look up cross section on your phone. Look up cross section on your phone. Let's get several people. Max, will you do it? Jadine, you have a phone?
Yeah.
Jadine's very poor. She doesn't have a phone either. So,
Cross-section.
does anybody have a phone? I have one person in here that has a phone. Patrice, you have a phone? Patrice has a phone. She's one of our wealthier students. We simply refer to her as the millionaire. Okay. So find out what cross section means. Anybody?
It's there's multiple definitions. The intersection of a three-dimensional body.
The intersection, the intersection of a three-dimensional body. Okay, this is a three-dimensional body. The intersection. Okay, I'm going to intersect, cross. Is this a cross? Is that a cross? Right? So I'm going to cross. I'm going to cut it like that. Right? I'm going to cut it. Now I have this. So this is the cross-sectional area. Area, right? Length times width, area. Right? You get that? What else does it say about cross-section? Max. Max is also one of our wealthy, I think I said that. We're very proud of him. He's a hard worker, and he made most of his money in the stock market. Yes, Max.
A surface or shape that is or would be exposed by making a straight cut.
Very long, very long, very long. But can you say it loud? Can you come up here? You don't have to be on camera. Just say it loudly right here. So read it right off your phone. You don't have to be on camera. Just right here, say it loudly. Don't lean on the day table. Shake the camera.
A surface or shape that is or would be exposed by making a straight cut through something, especially at right angles to an axis.
Get it? Yes?
Yeah.
Okay. So that's what cross-section is. So we know what a cross-section is. Do you understand that this is the cross-section of a wing? The wing is going straight out. The wing ends over there on the back wall. Really big wing, right? Do you understand that or no?
Yeah.
And I made a cross-sectional area. I cut the wing at a 90-degree angle, right? This way, right? You get it? Okay, now, there are two molecules, okay? Two molecules. There's molecule A and molecule B. You get that? Okay, two molecules, yes? Now, the wing is going to go through the air. The air isn't moving, the molecules are moving. You get that? The airplane isn't moving, I'm sorry, the air molecules aren't moving, the airplane wing is moving through the air, right? So the air molecules are going to end up over here. You get that? Here are the air molecules here. So then they're going to end on the other side of the wing, right? Correct? But are the air molecules moving relative to the wing? Yes. But relative to each other, they are not. Right? You get that? So, molecule A is going to go like this. Molecule B is going to go like that. Do you get that? Do you understand that? Yes or no?
Yeah.
You all right with that? Yes? Okay, good. Now, do you understand that the time, Jack, it takes for molecule A to go here and molecule B to go here, do you understand that the time should be the same? Correct? You sure? Okay, so in other words, molecule A is here, molecule B is here, and I'm going to walk through them. Okay? Right? So they ended up on the other side of me at the same time, right? Correct? So the time is going to be equal. Correct? The time is going to be equal. Right? Same time. What has a larger distance? Molecule A or molecule B? A has a larger distance, doesn't it? A is a large distance. Correct? Yes? Now, what about, now do D over A. Which has a larger velocity? A or B? Which has the larger velocity? Remember, velocity is distance over time. Which one has a larger velocity? A has a larger velocity. So this is A, and this is B. Does that make sense to you? Yes? Correct? Okay, now. You've all used a garden hose. Okay, this is a long garden hose, right? Long garden hose, right? Are you okay with that? Now, it's going to be screwed in against the house. We're outside the house. And it's going to be screwed in to the house, right? Yes? And this side of the hose has a sprayer, right? Has a clutch. You squeeze the sprayer and it shoots the water, right? But I'm not clutching the sprayer, so the sprayer's off, right? So the hose is all very limp, and then I put the water, I turn on the water, and it's going to fill the hose, right? But it's not going to squirt out, is it? So the velocity of the water inside the hose is what? What's the velocity inside the hose if the sprayer's not spraying? It's 0, right? Now let's say there's a hole in the hose. A lot of H's today. There's a hole in the hose. Okay? There's a hole in the hose. There's a hole in the hose. Now, the water is going to squirt out the hose, correct? It's going to squirt out 90 degrees perpendicular to the hose, right? Correct? Now, so can you picture this hose? It has a hole in it, and it's squirting out, right? So here's the hose, and it's squirting out the hole of the hose, right? Correct? Now, I put the sprayer on. What happens to the leak? It becomes less, doesn't it? Almost goes away, doesn't it? Almost to the point where it's just dripping, right? Easy? Okay? So, what happens to the pressure of the fluid? What happens to the pressure of the fluid when the fluid is flowing fast? It decreases, right? Now, normally, this is, let's say the wing isn't moving. We'll pretend, right? So this is the atmospheric pressure, right? This is not good. So the atmospheric pressure would be the same on top and the bottom, right? Now, the wing is moving that way. Moving that way. Where's the velocity of the fluid? Air is the fluid. Where is it greater, on the top or on the bottom? Where's the fluid greater, the velocity greater? Up top or on the bottom? Up top, right? So where would the pressure be less? Where would the pressure be less? Top, right? So the pressure is less here. So let's say the pressure is like this here, right? And it's like this here. What happens? Add those two vectors. What do you get? That's right. Max is going like this. Okay? You get lift. You get lift. Do you understand that? Yes? What's Bernoulli's principle?
When speed increases, pressure decreases.
When the velocity of a fluid increases, the perpendicular pressures decrease. Correct? Is that right? So the pressure would be less here than here. So it's going to go zzz, right? What happens if let's say this is a wing, right? Okay? I'm going to increase the speed of the fluid on top of the wing. See how it goes up? You see that? I'm reducing the atmospheric pressure on top. On the bottom, it's the same. That's called what? Starts with an L. Lift. You get it? Yes? So, you have four vectors. You have four vectors. What are they? The motion is going this way. That's the motion. And you have four vectors. You have four vectors. What are they? What's the forward vector called? What's the forward vector called? Thrust, right? What's the rear vector called? Drag. What's the downward vector called?
Gravity.
Gravity. Correct. What's the upward vector called? What's that vector called? Lift. Lift. You get it? Thrust, drag, gravity, lift. Yes? We're done. You get it? You sure?
Yep.
Positive. Okay. Bernoulli's principle.